And hopefully with this talk, and you feel it's very easy and peasy to fulfill this 12-factor kind of requirement. I am Emily Jiang from IBM. I'm the Liberty Microservice Architect, and I work on MicroProfile and Open Liberty. I'm the Java champion. So if you have any questions, feel free to ask on the chat. I will leave a few minutes towards the end to answer the questions. If your question has not been answered, please directly send me a DM or directly ask on Twitter. My Twitter handle, Emily FH Jiang. So it's, in this talk, I will split into two parts. So the first part, we'll talk about the basic concept of 12-factor app. So just a level set, what are these 12-factor app? And then I will spend more time basically demonstrate to you to do the live coding to build a 12-factor app microservices using MicroProfile and Kubernetes. So let's get started. So it's for the 12-factor app. So it's what is really a 12-factor app? 12-factor app is a methodology, best practice. Cool. If you want to find more information about 12-factor app, go to the 12factor.net. So why do we care about this 12-factor? Why is it so significant, right? So the most important thing about 12-factor app is that it established like a divider. So divide between the application and the infrastructure. Tell the application which is your responsibility, and also that for the infrastructure, what kind of quality services and etc. you should provide, so that they don't trap into each other's toes. Let me see some. So this is the TLDR version of 12-factor app. So it's as you all know, we live in the kind of the modern era. So basically is software as a service and platform as a service and etc. So 12-factor app is the kind of is the best practices and also methodology for building software as a service. So it set up a clean contract between the application and the operating system, and it's suitable for deployment for cloud platforms. Once you have used the 12-factor best practices, you can minimize the divergence between the development and production. So, and then you can do a CI/CD development and deployment method. And also your app can scale up without any significant changes. The other thing I want to mention is the 12-factor is language agnostic. So you can use this 12-factor for Go and for Java applications. So in this talk, I will just talk about Java. So 12-factor app called 12-factor app is because it has 12 factors, like from code base to admin processes. So later on, I will go through each individually to talk about them. So the other thing is that's why, and then how then, okay, is I mentioned that it's very significant to fulfill this 12-factor requirement. So how? So luckily is MicroProfile and Kubernetes come to rescue. So they can help you to build a 12-factor app. If you do it yourself, it's going to be a very daunting job. Just a few words about MicroProfile. So MicroProfile has been around for 4 years, is under Eclipse Foundation. Recently, we set up our own working group, which means so MicroProfile has become a standard. So standard is provide standard APIs for building cloud native applications, for building microservices. So it's similar to Jakarta EE, if you know Jakarta EE or Java EE. MicroProfile community is very diverse in terms of contributors and also implementations. So contributors from many companies, including me from IBM and some of my colleagues, and also Red Hat, Piara, Tommy Choi, Lightburn, and also there's some other individuals. So I welcome you all to contribute in MicroProfile community. And also, it has about a dozen implementations. So in like IBM, we have Open Liberty, WebSphere Liberty. Red Hat has Quarkus, Wildfly, and and also others like Piara, Tomy, Halidon, Fujitsu, Cumulus-E, Hammock, Prana, Apache Geronimo, and list is still going on. So from time to time, I find out more implementations available. So this demonstrate open standard. So demonstrate this is kind of the is a standard way for building microservices. So this is a quick timeline about MicroProfile. So we aim for 3 releases per year. And this year, with the exception of this year, because we spend more time to set up a working group. So next release is the MicroProfile 4.0, hopefully is in November time. So the latest release is MicroProfile 3.3. So this is a quick bird's eye view of MicroProfile. What's there? Like it has open tracing health metrics, open API for tolerance, GWT config, and etc. If you want to do reactive, there's a reactive messaging, and also there's a GraphQL and long-running action for doing transaction. So this one, LRA, is to be released like in November or December time. So that's a quick run through MicroProfile. So next we'll talk about these 12 factors in more details. So the code base is kind of, you need to do the reversion control. So nowadays, a best practice use GitHub. I think you can have this take. Most people use GitHub already. So the second one is the dependencies. So you manage your dependencies using Maven, this POM XML to pull in your dependency. And similarly, you can do the similar thing in Gradle. I think, again, most people can fulfill this requirement, second factor. So do not prepackage your dependencies inside your application. So always loosely couple your dependency using the Maven dependency or Gradle dependency. So third one is configuration. You should always store config in the environment. So in this way, you can change your config without repackaging your application. You can use the cloud infrastructure. You can use the Kubernetes config map or secret to store the config value, and then you use the MicroProfile config to inject the value into your application. So here you can use like a config provider that get config, and then you can look up each individual properties, like using like a get value, this call. Or you can use the CDI to directly say, okay, which property I'm interested, you can directly inject into a variable. So the next one is the backend services. You should treat backend services as attached resources. So basically, for example, here, if you want to do a social media and you have a API, both implemented by Twitter or by Facebook. And then if you are not happy with Twitter, you can directly swap into Facebook. So here, the MicroProfile REST client directly can help you with that. So you can, in your caller, you can just create an interface with the API and then annotate with register REST client, and then you can inject that interface into a variable. You can directly call any method like call get properties on this variable. And how can you bind to the backend? So you can use MicroProfile Config. So fully qualified class name, like a system client, macro slash np rest and slash URL. You can supply the backend URL there. I will do a demo later. So the next one is the build, release, run. You should strictly separate build and and run stage. So every time when you do a source code change, and you should build it and then test it and then release it and then run it. So you should consider to use CI/CD pipeline such as Tekton. So if you have not heard of it, go and check it out. So the next one, the processes. You should execute the app as one or more stateless processes. So it's kind of your microservice should be stateless and share nothing. So basically, Kubernetes can directly queue like instance at any time, and you don't lose anything. So you should treat as cattle, not pet, because all of them are same. If it's a cattle, you can grow a bigger herd or shrink into a small herd, but pet they are not replaceable. So the next one is the port binding. So you should export services via port binding. So you know the port most will change when you deploy your microservice to the cloud infrastructure. So you do not don't like hard code a port. So once you deploy it to the cloud, you will get a map into a new port. So you can use, if you do need the port number, you can use config to directly inject the port into your microservice. So the next one is concurrency. So this one means your microservices can scale up or down based on the workload. You should consider use Kubernetes auto scaling to scale it based on the workload. So the next one is disposability. You should make sure your microservice fast start up and gracefully shut down. So which means you don't pay like money for the time you have not used, your application is not functioning. So you should choose a lightweight runtime. And also you should make sure your application, your microservice is robust. Should consider use fault tolerance to make it resilient. So fault tolerance has a few annotations like a retry, circuit breaker, bulkhead, timeout, fallback, and etc. here to help you to create a resilient microservices. So the next one is dev product parity. So you should keep dev and staging on the production stage as similar as possible in terms of code and people and etc. You should use the kind of the stable deployment models such as operators or Helm to deploy it in a repeatable manner. So the next one is logs. You should treat logs as an event stream. So the best practice is you should system out logs straight away because your pod could disappear any given time. So the minute you have any logs, stream them out. So in this case, if the pod destroyed, you lose nothing. And then you should directly connect with the ELK so you can gather and produce any chart and etc. So the final one is the admin processes. So you should run these processes as one-off jobs, such as you can use Kubernetes jobs and use kubectl exe. So don't put these admin processes inside your microservices. So this is a quick run through this 12-factor. So code base, you use GitHub and dependency, Maven, Gradle, config, backing service, processes, port binding, disposability, you can use MicroProfile, and also the concurrency admin process, you can use the Kubernetes, like a build, release, run, and dev product parity and logs. So this is the best practices. So this is kind of covered all these 12 factors. So let's just get started to demonstrate to you how can I create a 12-factor app. So how can I get started? There's a few ways to get started. So using MicroProfile to create 12-factor app. So you can go to start on microprofile.io, this is starter, or if you use the VS Code, you can use this installed MicroProfile extension pack, or if you use the IntelliJ, install the MicroProfile starter. So for me, let me try to use the starter.microprofile.io. So it's basically, so I can, this is the kind of the starter of MicroProfile.io. So I can I create a microservice. Basically, it's create a microservice A directly. This one I want have the 3.3 latest version and running on Open Liberty. And then I want to demonstrate the health and also REST the client. Basically, in my architecture is I have two microservices. Service A running on Liberty and directly talk to service B running on Quarkus. So let me create a service A. So I just do download. Is me. So it's let me start a service A. So let me start a VS Code. So this is the service A. And also is in order to save time, I already create a service B running on Quarkus. So here is my, let me go to my service B. So the service B is already up running. So basically the service B, I want to make a service A directly call into service B, do something. So here is get operation, take a pass param and to do something. So how can I do that? So here is the service A I created. So it's I use a MicroProfile I use the MicroProfile REST client. So basically, I create an interface. So this do something, take a pass param, which is a service B's like a method. So the signature and the get operation. So I just directly annotate the register REST client. And then I can use at inject REST client and inject into this service. And then I can directly call this service. So next thing is I need to tell the service A where service B lives. So basically, so this is my service A. So this is my service B. So service B, I can start Quarkus dev. So I can start the service B. So it's you can see service B is on the port 8080. So I know already. So it's on the port 8080. So let me start service A. Service A is running on Liberty. Liberty also has dev mode. So Maven Liberty dev. So what's the dev mode means? Dev mode means you can do your development, and whenever you make a change, the plugin can restart your application, pick up the changes straight away. So while it's starting, so the next thing I want to say is I would like to configure my service A. So basically, I want to say something about we are live at JCON, but I want to make sure don't want to hard code that. I want to make if I change it to be a different conference, I can inject this one. So with that, I can say at inject at config property. I want to inject a conference. So I can inject the conference there. As you see, so service is up. So it's I inject the conference somewhere. I need to like specify is not here. I have the plugin MicroProfile VS Code extension. So it tell me the conference is not set. Let me set the set is somewhere. Let me set into the application. I say conference equals JCON. Do like that. Let me save this one. Let me go in here. So it's that is kind of the so it's my service is listed on the port 9080. So now this is the REST client directly calling to the service B. So I click on it, nothing happened. It's because I haven't wired them up as yet. So let's wire them up. So it's so here it said this is what's a fully qualified class name, com example, and liberty, and then it's kind of the service. So as I know, it's not on the 9081, it's on 8080 service B. Let me save that. Go back here. So directly call into the Quarkus service B. So as you know, it's Quarkus service B because so this is exactly said this Quarkus service B. As you can see, I put some bug inside the service B. So service A and sometimes not behaving when the call into service B. So like sometimes it's really slow. This time is really slow. And then sometimes you get exception. So for example, you own service A, how can you like make sure your service A is resilient, is always working without needing to change the backend. Sometimes you can't even change the backend because you don't own that code and etc. So I can use MicroProfile fault tolerance. I can say retry, please do a retry if something not working. As you know, it's also sometimes is kind of slow. I can say actually at most I can wait for like a 100 millisecond. Otherwise, I won't be able to like wait forever. So I can use the timeout. Whenever you use a timeout, the best practice always use asynchronous. So make sure you use a different thread to directly like to run this operation. Once you use asynchronous, you should return a completion stage. And then you should here you can use a completable future from Java 8, and then you can see completed future. So here, and then it's the other. Let's see that, save that, and then let's go back here. As you can see, it's always working. So that's because if it's slow, you get timeout exception and a retry kick in, and then you get like a good response back. So the other best practice is whenever for the critical service is always best practice to put the fallback. So basically, if something goes wrong, and you know is you should have a contingency plan. So here again, so you need to define this method fallback. So the language server support can give you the error, so you need to fix it. So so now I define the fallback method. Remember, this one signature need to be exact same as this one as the main method. So obviously I said instead of calling into the backend, maybe you just hard code to say this is my fallback. In the real time, you might like if you use a banking, you might return a caching service or something like that. So this is pretty much like demonstrate how can you configure your application and create like a resilient microservices. So the other thing is the health. Basically, you can also like plug in the liveness and readiness the check. So for liveness, you directly like implement the health check, and you can in this method you can say under what kind of circumstances is up or down. And similarly for ready is, I mean, if you have a database access, you can say is if you cannot connect to the database, you had better to sit down because you can't really serve the like a request and etc. So this is pretty much like from this coding aspect. So let's go back here to see whether everything is okay. Again, it's there's a kind of with the MicroProfile health. So you have like a health live. You can see there's a JSON, it's JSON display, and also there's ready. So you can plug in with the Kubernetes readiness and liveness check. So that's pretty much finished all your development, and then you can check into the GitHub. So, and you have two repo, one is service A, one is service B. So next thing is I want to like containerize it and deploy to Kubernetes. So with that, I need to like build this one. Control C. So I can use Maven directly, Maven verify to build it. And for the service B, so this is expected because that's a plugged in error. So service B already built the Docker image. So build the project, and now I can directly copy. I have my cheat note. So I directly can copy my Docker file. And now I can do a Docker build here. So while it's doing, let me show you the Docker file here. So for the service A, I use the Open Liberty kernel and directly copy the config and copy the couple files, bootstrap.property and server.env, and also copy the wall. And then I run config.sh to optimize this Docker image. And similarly for like a service B, so that's on Quarkus. So I directly use Fabricate, and again I copy this one, I copy the Jiang, and then yeah, directly build that Docker image. So while that doing, and also I show you the deployment YAML file. So once I have two Docker image, one Docker image is I already built is Quarkus service B, and with tag is 10. So the other one is service A. So I'm currently building the Liberty service A 10. So the other thing is that I showed you earlier. So the conference, I I put inside the application, I said JCON. Now it's in my deployment YAML file, I can specify a new value. I say JCON 2020 as an environment variable. So this one will overwrite inside the value inside the application. The beauty with MicroProfile config is all the config sources such as MicroProfile-config.properties or environment variable system properties or any other customer config sources. They all have ordinal, so they like the environment variable has a higher like a 300 MicroProfile-config.properties has 100. So it's this one will overwrite the inside the application one. So the other thing is, previously I told the service A, I put the com example liberty client. This is where my service B lives. Obviously, once you deploy to Kubernetes, your service B is no longer in that localhost 8080. So it will be somewhere different. So the beauty is that you can also configure that. Obviously, previously I configured inside the application here. I say com, so all the dot, right? And then dash and slash and etc. However, because this is kind of specifies environment variable name only accepts a number or alphabet and underscore. So all the other illegal ones transformed into underscore. So this one I can specify new like a endpoint. So the other one is the service A. I know I have the 9080 health live and then and health ready, so that can plug into the liveness and readiness prop in Kubernetes. So this is deployment for service B. And then you declare the service. So the service, and also like a service A, I want declare it as a node port, so I can access from my external. So and then it's kind of the external traffic policy and etc. And service B, I declare the cluster IP is only accessible inside the cluster. So its port is 8080. So the other thing is for the deployment is I declare the replica is 2. So both of them like replica is 2. So this is all the like already, and this is already. So if I do a super control, I already deployed to the Kubernetes. So if I say, so it's already up and running because previously I like get that. However, if I do a delete them, they will be deleted. So it will be terminated, and then it's later on it will be disappeared. So disappeared. Now I just apply. This, so it will be create all of them. It's so it's like this 2. You can see is each service has 2 deployment. So it's so these are all up running, and then you will see the services, and you can see here is a node port is bind 9080 to 380. So if I go here, I will say localhost 380. You can see is this my service A, and this one directly call to the backend. Can see service B is not ready and then kick in my fallback. And then now service B is ready and directly call into the backend. So with that, I think is pretty concluded my demo. Let me go back to the presentation. So this is I demonstrate a service A directly deploy to OpenLiberty, can talk to service B deploy to Quarkus. You all use the MicroProfile. So it's I use MicroProfile Kubernetes to fulfill this 12-factor app. So like a service A and service B can check to GitHub and dependencies for the dependencies, one thing I quickly show you is in the dependencies, all you need to do is kind of directly add this, nothing more. So it's in Quarkus, you have like a few extensions on OpenLiberty, so in OpenLiberty, you directly is only one dependency, directly depend on the MicroProfile 3.3. And then this is all the OpenLiberty's plugin. The next thing, the config, you use the MicroProfile config. And backing service, you use MicroProfile REST client, build a release run, we do a Docker build, and then we do Kubernetes apply -f and then run it. And the processes, you can use, we use MicroProfile REST client to create RESTful microservices. So they are stateless, port binding. You can use MicroProfile config. Concurrency, I demonstrate, I didn't use the auto scale. I use I show you, you can use the replica, but you can use Kubernetes auto scale to directly configure when to stand up a new instance. Disability, I use MicroProfile fault tolerance to make sure the service resilience. And dev prod parity is kind of, you make sure when you finish your dev, you Dockerize it, and then you don't have surprises in the production. And the logs I haven't demonstrated. If you want, you can directly system out some logs. Admin processes, again, is I haven't demonstrated, but if you have admin processes, you use Kubernetes jobs. So this is the useful links. And if you want to learn MicroProfile, go to microprofile.io. And also there's a very nice guide in the OpenLiberty side, openliberty.io/guides to learn all about MicroProfile. And also there's a good guide in the Quarkus, go to quarkus.io and learn 12-factor and Kubernetes. All my example checked in here, and you can check it out and do the experiment yourself. So with that, I think I'm done with this. Let me see whether there's any questions. Let me see. So I have not seen any questions. Okay, so I have one question come up. Is there, is there a possibility to edit the Docker YAML with an editor instead of code? Yes. You can use any editor. I think it's VS Code has some YAML kind of checking and etc. But YAML is not my cup of tea. I don't like white spaces. Actually, if you follow me on Twitter, recently I launched a survey regarding whether compare YAML with XML. which one is better. So it's kind of yeah, it's some people a lot. Yeah, I think it's probably over majority of the people responded kind of is do not like YAML because the white spaces and etc. Yeah, so large Docker configs are not large Docker configs are not really readable. I don't I mean, understand what you mean the large Docker configs are not readable. Do you mean the config, do you mean the config map or secret? You could click to access. Oh, I see. Okay, so that's a good idea. Can directly generate YAML in the background. That's a great idea. Yeah. Okay, so macrometer. So it's there's a talk about macrometer like a bit later today. Yeah, it's recently, it's in the past probably 3 months, we talk about MicroProfile metrics is going to adopt macrometer. Yes, we are going to in the MicroProfile 4.0 to be released in November. So that's still based on the drop wizard. But for the next release of the MicroProfile metrics, we are going to adopt a macrometer. So at the moment, we are trying to work out how can we minimize the migration pain from a drop wizard to macrometer and lift what we have provided over above drop wizard, like all the annotations, all the kind of metrics. You know, you have vendor metrics, basic metrics, application metrics. At the moment, there's endpoint slash metrics and etc. Also trying to work out, whether we need to keep this kind of capability or not. But we do want to adopt a macrometer. Yeah, please tune in to the tune in to the next talk to learn more about macrometer. So actually, it's we have been talking about a macrometer in MicroProfile for quite a while now. So it's great. It's a great library. So that's good. And then the other things, the future of macrometer, and people also talk about maybe it's, donate a macrometer to like a CNCF or somewhere some other standard body or something like that. But I heard good feedback on macrometer. So this is also demonstrate how rapid and innovative feature of MicroProfile. So basically, we're trying to make a change, adapt to the demand all the time. So we don't want to stuck with one technology forever. Thank you for attending this talk. Yeah, enjoy the session, the following sessions. Thank you. Bye.